Find the population standard deviation for the number of, do these values represent a different story about the two fishermen, the population standard deviation for the number by Ethan and Drew. Okay, so I'll go back. It's the population. So we are using sigma because we have the entire data. Okay, so sigma for Ethan, 6.6295. And sigma for Drew, 4.9608. Tell me how about your own data. Did you get differences? I'm just curious. Can anyone give me the mean and yes, the mean for both? From what you...
the mean and the range were the same for both, for my people, Ethan and Drew, but
okay.
The standard deviation was different.
Okay. So I got my standard deviation for the first one was 6.6 and for the second one was 4.9. Did you get a bigger difference?
I had 4.8 and 7.9 for my data set.
Okay. So there are differences. Good. So enter them. Good. So you will say, do these values present a different story about the two fishermen's catches per day? The answer is yes. Which fisherman has the more consistent record? The one with the less spread. More consistent means more to the center, not too far away. So see, the numbers here are clustered closer together than 1 and 2 and 20. So 1 and 2 is here, 20 is here, so the spread is larger. Unless I put them, I inverse them. I may have inversed these two. But obviously this appears to be more dispersed. Okay, can we move on now to the next problem?
What did you say for the last two questions on the Ethan and Drew question?
The one with a wider variance, I don't know which one is yours, but the one with a wider spread is less consistent because its numbers are further apart from the mean. When the standard deviation is smaller, the catches per day are clustered closer. They are closer to the mean.
So, okay, just one more question. Which fisherman has a more consistent record?
The one with the smaller, I don't know in your case, the one with the smaller variant, with the smaller standard deviation.
Oh, so that's Drew then.
I don't know. I don't know if you have the same numbers.
I did have the same answers as you did, so.
Okay, so the one with the smaller spread is more consistent.
Okay.
Find the sample variance and standard deviation. I think we have okay with this. I would like to move on so we can get to probabilities. So is it okay if you do this problem later? It's the same what we just did. Sample variance and sample standard deviation is just that you will have to use for a problem, is it problem 4, yes. You have to use SX because it's the sample now. This was the population. You have all the information, nothing is left out. But for problem 4, please use SX and then SX squared. Can we move on? You can come back and finish that later. Is that okay? We can come back to other problems. I just would like to do a little bit of everything, not just one type, one chapter. Maybe we should jump around. I didn't think we would need so long for a couple of problems. Is that okay if we move on?
Yeah.
So let's see what problem 5, let's read problem 5. We'll come back to it. If we have time, we'll come back to it. No problem. So what are they asking us? They're asking us to find the z-scores. We want to find a couple of z-scores and then move on. What is the mean of the z-scores at all times? So if you look in the body, it says compute the mean of the z-scores. The mean, remember the z-score is a normal, we don't know that yet, forget about that, 0, 1. So the mean for z-scores, you don't ever have to calculate it, is 0. So mu for z is 0. And the standard deviation for z is 1. Do not ever calculate those. So you can already enter them. The mean of the z-scores is this, and the standard deviation of the z-scores is that. Done. That is always the case, and we will use them later in the course. So let's find the z-score for student, which pick 2 students, and let's find the z-score. They are not giving us the mean and the standard deviation, however, so we have to calculate. So what I see is 77, 61, 60, 81, 72, 80, 80, 68, and 73. Okay, so I have to find the mean because the z-score for student 1 will be his entry, 77, minus the mean over the standard deviation. That's the formula for the z-score. So 77 minus over the standard deviation, and I have to enter the data and quickly find the mean and the standard deviation. So I'm clearing 77, 61, 60, 81, 72, 80, 80, 68, and 73. So I have 73.233. Just 2 decimals are enough, depending on what it says. So keep in mind what, but I would use for the standard deviation 4 decimals. So this is the z-score. Do not forget to use parentheses in the graphing calculator for the top. So 77 minus what I got, 73.23, and I divide by 7.3236. So the z-score for my first student is 0.5148. We should only use 2 decimal digits here. So 0.551 would be fine. And we will have to determine the z-scores for all of them and enter them. Any questions on the z-scores? It says round to the nearest hundredth as needed, so yes, 2 decimal digits enough. This was problem 5. Let's continue with 6, and you can go back. We can go back and finish it up if you want when you can. Okay, we're moving on to problem 6. We have 3 parts, part A, B, and C. We have 28 data entries, and we're asked to find the 5-number summary. So let's put the data in either StatCrunch or a graphing calculator. I'm entering my own. So 2, 4, 6, 7, 7, yes, 28. Just make sure you have 28 entries. You do have to enter the 0 because if you have 0 because of the number of entries. So you have to have 28. Do not disregard the zeros. I'm not saying you would, I'm just saying don't forget. Don't say, oh, it's 0, why would I enter it? I have 28, yes, I have 28. So now again to go to stat, 1 variable statistics for list L1, and the 5-number summary, starting with the minimum, min, Q1, Q2, Q3, max. 5-number summary, and I copy them. 0.01 for my example, 1.63, scroll further down, 2.76 in my case, 2.95 and 3.6. So this is my list of 5-number summary, and now I have to identify the correct box plot and then identify the shape of the distribution. So here's what I do my work on the number on paper, because I don't know which one to pick. So this is my minimum, 0.01. So 0 is somewhere here. 0, 1, 2, 3, 4. Okay. 3.6 is somewhere here. 2.95, so this is 3 and this is 2 and this is 1. 2.95, somewhere here. 2.76, quite close. 1.63 here. And these are the whiskers. And this is my box plot. And in my case, it clearly shows that the median, and remember what this represents, the middle 50% of the data. So this is the median, Q3, Q1, min, max. Any questions on this problem? In my case, I would say that the distribution is skewed to the left. Are we in the clear with this problem, problem 6? You think we can move on?
Yes.
Okay. We can come back, and if you have any questions, I'm just clicking on not enter in my case. So the next problem has a correlation coefficient given to us. And that is, in my case, negative 0.2209. That's my problem. And n is 10, let's say, in my problem. Okay, what would be the predicted stock return for a company made? Okay, what would be the predicted stock return for a company who's made? Okay, so when we have 15 million and 25 million. Click the icon. We have a sample of 10, and for 10, the R critical value in the table is 0.632. I'm entering the data to find the linear regression model. So let's enter. List L1, I clear. List L2, I clear. So 25.92, 4.06, 19.11, 13.28. 4.54, 1.81, 26.12, 14.93, 17.23, and the last one, 14.04. I'm making sure that I have 10. Yes, I do have 10. I'm entering now the stock return, 5.77, 30.44, 31.97, 79.4, negative 8.2, 3.03, 4.54, 10.63, 4.24, and 12.22. Okay. So now remember, we go to Stat, Calculations, and we use number 4, Linear Regression. And the linear regression is on list L1, comma list L2, and I want to store the equation, go to Variables, and go to Statistics. Oh, no, sorry, go to Variables, Y variable, Function, and Y1. Okay. And now, and I removed the, I have to go to Diagnostics because I removed the battery. I spilled water on it, and now I don't have the diagnostic. So let me go to D. Okay, here it is. We've done this together. You don't need to do it again. I have to because I messed up.
Professor,
yes.
Are you using the line of the linear regression?
Yes. Yes.
Problem?
Yes. Yes.
So with the data, we needed to find the standard deviation and mean.
No. Because once you punch in the calculator, it gives you the linear regression line already. Yes, you don't need to determine. So this was negative 1.132x and plus 36.49. The calculator gave me a slightly different linear regression than the one coefficient than the one given by them, as negative 0.2915. It is possible that maybe I missed something on the data set. That's very possible. I'll have to check. See, that's why it's so important to show me what you're doing, because you may enter the data incorrectly. That's possible. I will not hold that against you. I will look at what you entered. I will look at see what you came up with. Okay, and now we go to second and table, and they're asking us to find for 15 and for the predicted and for 25. So y hat for x equals 15 million. I got 19.51, and for 25 I got y hat 8.11893.